In the soccer league, we have different classes. So there are humanoid robots, again, some custom built, some standard platform. We have wheeled robots, big size, small size, and they're all testing different things. So for example, as mentioned, the standard platform, because we're using the same hardware, the competition is more on the programming. When you've got the hardware, it's much more on the motors and control, things like that.
In that standard platform league that we've been involved in for about 20 years, we started off with the Sony iBo, which was a 4-legged dog robot, and now we're on the Now, which is a humanoid, 2-legged humanoid robot. So we managed to get the dogs going really quickly. The humanoids are a bit slower, but you can see advances every year. And when we started off, there were a lot of cues around the field to help you figure out where you're located on the field, where certain things are on the field. So for instance, where the ball is, where the goals are, where the opponents are. And now you've slowly had all those cues removed. So the goals are white, the field is white. We use a standard black and white soccer ball, which is, albeit smaller than a real size soccer ball, is much more difficult to detect than the early days where you had an orange ball and you had beacons on the side of the field.
In the humanoid league, there are 3 different divisions. There's the kid size, the teenage size, and the adult size, and they're based on the actual physical size of the robots. In the humanoid league, you have to design your robot physically, and you also have to create the software. So the difference there is that we do the mechanical design as well as the software, and we're able to change the configurations of the robot. So we can use different microprocessors, we can use different cameras, we can use different motors. The rules are written such that the humanoid robots have to actually have humanoid characteristics. Their body shapes have to be similar, their legs can't be up to their chest, they have to have the same proportion to a human body, and they can only have the same sensors of human. We can't put laser distance sensors to work out how far the opponents are away. The only sensors that we can have are sight and audio, if they've got smart enough to do the audio.
The reason why we have wheeled robots, even though they're not very humanoid, is that the control of those robots is much more precise. That we still have trouble, say, with the legged robots, balance, and also there are a lot of problems in the control of the walk, for example, that we're still working on. Whereas with wheels, it's easier, so you can actually play a more realistic soccer game, if you like, with the wheeled robots, because they've got more control, they're faster, they can pass more accurately. So all of these things are kind of testing different aspects of the gameplay.
But the interesting thing about the soccer competition is that you need to do things quickly. So you don't have the luxury to just sort of sit there and do a lot of computation and so on. By the time you figured something out, the ball's no longer theirs. To me, it's about the technology and, all the work that goes into being able to do tasks like the robots figuring out where they are on the field, where the ball is, where the opponents are, the strategy layer that we have in terms of how you play the game, just as humans would have a high-level strategy when they play the game. I think there'll be many industrial applications, but just to give you an example of one that's come out of our team, there was a person that competed for us one year, and they set up a company where they were trying to make a saw in a sawmill safe for the operator. So the operator was having to feed the timber into the saw, and of course you're worried about the hands getting too close to the saw. So the operator would wear coloured gloves, and we had a lot of code in those days that would easily pick up coloured objects. And remember, in robot soccer, you've got to do things quickly in order to be able to compete well. So he was able to develop this software that picked up the hand movements very quickly, and if they got too close to the saw, would cut the power to the saw. One other industrial application that I've seen from another team was in the middle-sized league, where they developed what's called an omnidirectional drive. So the robot could move in any of the 360 degrees instantaneously. And they put that into a wheelchair. And if you think of wheelchairs with 2 wheels, you've got to do a lot of maneuvering to move around. Whereas this sort of wheelchair could move in any of the compass directions instantaneously.